Right. Bacho, now actually I'm going to start one more replica actually paper of advance, what I have created. Okay. These all questions are again replica of JEE advanced papers, previous papers, right? So today, I think 21 question we will discuss. 21, right? So you start with first question, right? And see, read the question very properly. Then only you'll get answer. This is section one or more than option correct. This is section one or more than option correct.
Sir, BC.
B and C. Okay. B and C. Okay, right. So, everyone, what the answer you are getting for this question? B and C.
Yes, sir.
Yes, absolutely. Answer is B and C only. Any doubt is there in the question? In this question, the answer is B and C. Any doubt? Because this first and second reagent is basically hydroboration oxidation, right? So in hydroboration oxidation, obviously you know that the anti-Markovnikov addition of OH. So here we'll get OH at this point, right? At this point we'll get OH. At this point we'll get H. OH replaced by Br, PBr5, and that Br replaced by zinc and HCl reduction process, NERBr. Okay, so in this case, in this case, second case, it is like anti-Markovnikov addition of OH, and here we'll add OH. OH replaced by Br and RBr on the reduction with zinc and H plus that you have actually seen in hydrocarbon chapter itself. You will get compound RH. Like that, the compound P will be the final product if I use the reactant B. Same with the reactant C. Right, again here anti-Markovnikov addition of OH, OH replaced by Br with a third reagent, and both Br reduced by zinc and HCl again become CH3, and that will become CH2CH. Okay, now see this question. In this question, if anyone is having doubt how to convert the Haworth projection, like how to show the Haworth projection, how to convert this Fisher to the Haworth one. If you don't know, then we can discuss, right? This type of question they may ask, or they may use this like conversion in any of the questions. This is the Haworth projection given for glucose. So you need to check which Fisher projection is correctly matched with this Haworth projection. That
CD.
Which one?
CD.
CD. Okay. And C and D both are enantiomers, right? So for both enantiomers, we are having the common Haworth projection that you are saying.
Yes.
So means whether it is D glucose or L glucose, we will get the same Haworth projection that you are saying. It's a bit funny, na? D and L, both glucose are having the same Haworth projection, isn't? So what the answer you are saying? Answer is B.
C, sir.
C. Okay. Should I explain?
Yes, sir, C.
Okay, right. Absolutely. The answer is a C itself. Should I explain how to convert these things? Anyone? Now you see. Beta, suppose this is the compound. Let's say D-glucose, CHO, CH2OH, and here HOH, HOH. Please see everyone. HOH, then OHH, and then HOH. Like this is suppose D-glucose. Like this, they have given suppose D-glucose, right? Now you do simple one thing only. You just lay down the compound. You just lay down this compound like in a horizontal manner, like this. Like this. When you lay down this compound, the CHO will be like this side, and this CH2OH will be on this side, right? And when you lay down this compound right like this way, then this OH will come down like this. This OH will be like this. Next OH, again it will come down. This OH, again it will come down, and remaining are the hydrogen, 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 and this hydrogen. Now you do one thing. You just actually write this compound in this manner, it just try to write the compound in this, like in this way, so that we can create the ring. So this is suppose CHO as it is, this OH as it is, this OH as it is, that OH as it is, this OH again as it is, and here CH2OH, and here we have H. Now we know that this OH actually attack on aldehyde, then only we get this cyclization, right? So OH will attack, not CH2OH, and CHO is here. So this OH should come on this place, this should come on this place, this should come on this place. You know that technique, that one kept fixed, this bond you keep fixed, other three rotate in any way, that will not change the configuration. You know that rule? In optical isomerism, one you keep fixed and other three rotate in any of the direction, that won't change the configuration. So I am just changing the color. If I keep fix this bond and rotate other three structure, right, that won't change the configuration. If I do like this, now I'm getting the picture like this. Now I am getting the picture. CH double bond O. Here we have OH. Here we have OH. Here we have OH. Now this OH come on this place. That CH2OH come on that place. H is on downside, that I am not showing. Now this OH will attack the aldehyde compound, as this compound OH is attaching here. Now what I am getting, this CH, so H or OH, or it may reverse also, because this is sp2 carbon. sp2 carbon, if you attack, OH may come up, H down, or H may come up, OH down, right? Anything is possible. Remaining are on their own position, what we have fixed previously. Now, this way we can change the D or L configuration of glucose into this Haworth projection, right? And this is a new chiral center now. So that can be any one of the side, either OH down or OH up. If OH down and this is up, this is the alpha glucose. If OH and CH2OH on the same side, both are up, that become beta glucose. Bacho, you got this idea?
Yes, sir.
That's so simple. Yes. Now go in a reverse manner. This compound is given. Suppose this compound is given, and you know that this was previously aldehyde. So what you do, simply do this protonation here, break the compound, give backup from O side, that will again become CHO, and here we have OH, right? This way only. One more question is the reaction leading to the formation of 1,3,5-trimethyl-benzene, right? What is the name of this compound? What I have given, 1,3,5-trimethyl-benzene?
Mesitylene.
Exactly. Yes. So how many of the reactions can give mesitylene as one of the product? Mesitylene as one of the product. Just see carefully. That kind of question already they have asked with different reagents. I have used again different reagents. Just check properly. How many can give mesitylene? Tell me, what is the answer? Someone gave answer BC. Agree, everyone? And answer is absolutely correct. Answer is BC only. Should I explain this? Double H with this hydrolysis will give CHO. All three CHO with the red phosphorus HI reduced to CH3. So B is okay. BH3 reduce carboxylic acid to CH2OH. CH2OH. With the PBr3, CH2Br. And all three Br reduced with the zinc with H+, right? That will become CH3, and CH3. So BC will be the correct one.
What happens in A, sir?
A is not actually Wolff-Kishner. If it is a double bond NH2, you know that Wolff-Kishner reaction, beta, RCHO if you react with NH2, NH2, so first we will create RCH double bond N, NH2 followed by KOH, alcoholic, if you remember ethylene glycol, then we will get the compound RCH3. But actually it looks like Wolf Kirchner, but it is not, because double bond N, NH2 should be there. That is why it may create some illusion. Okay, move to next one. This question is again good one. Check. The same kind of question they have already asked in JEE Advanced. I have created the replica. Toluene react. This question is actually not tough, but good one. Toluene reacts with acid, considered HNO3 and H2SO4 at 288 Kelvin to give three compounds: P 60%, Q 35%, and R 5%. The major product of the following reaction sequence is S and T. They're asking about S and T. Asking about S and T. Now, they are starting the reaction with P. What is P? 60%. So first you need to check when toluene is undergoing nitration process, what will be the 60%, what 35 and 5%. That 60% part is going to react with the reagents. And then you solve the question. That kind of question usually JEE Advanced ask, which is not tough, but take bit time. Okay, first of all, you tell me what is P, what the product of P you are getting from the theory part.
Para-nitrotoluene.
Para-nitrotoluene. Actually, this is only wrong. In toluene, especially in toluene, I'm not discussing about ethyl benzene. I'm discussing especially about methyl benzene. If you read Peter Sykes, especially for methyl benzene or toluene, they have mentioned the ortho is a major product except the sulfonation case. Except the sulfonation, because SO3H is a bulkier group, except the SO3H. If toluene is reacting with any reagent, most of the time, ortho is the major answer, like nitration, bromination, even Fiedel-Crafts alkylation, acylation, except sulfonation or any halogenation, like the ortho will be the major product. So the P should be orthonitrotoluene. If you start with orthonitrotoluene, you will get the correct answer. Can you try? One more time. You start. Always remember toluene in a nitration. First major product will be the ortho product. Bromination, nitration, Fiedel-Crafts alkylation, acylation. Ortho will be the major answer, right? So go with the ortho product and then start the reagent process. You will get the correct answer. Okay. Bacho, should I solve this?
Yes, sir.
Yes, sir.
Okay. So suppose the initial P was like orthonitrotoluene, right? This is the compound. If I do bromination, as per the product, this orthonitrotoluene, which is actually P, this is actually P and 60% major product. Now, in this case, if you do bromination, the activating group is methyl only. And nitro or methyl is orthopara, nitro is meta. So both are activating the same position. This position is meta for nitro and para for methyl. So Br. Now tin HCl will reduce the nitro into NH2. NH2 bromination. NH2 bromination is a tribromo. But for tribromo, we have only two positions here. It's a one ortho is occupied by methyl. Now NaNO2HCl will give diazonium. NH2 convert into diazonium, and diazonium reduced to simple H by ethanol heat or S3PO2 heat. So it will remove from this point and you will get this compound, which is basically S. So answer C is matching. Now P. Now in second case, if we start, okay, we'll start with here only. We have this orthonitrotoluene. I'm starting here only. Orthonitrotoluene. Br2Fe, para position Br. FeHCl reduce the nitro into NH2. Now nitration. In aniline nitration case, Para is the major product. If you remember, in NCERT, it is given that para is major, then meta, and last one is ortho. If you remember, aniline nitration case, 51% para position, 2% only ortho, and 47% meta. If you remember. After then NaNO2 HCl diazonium, ethanol reduced. So this NH2 gone. Finally, nothing is there. Now this is the T. Now T undergo 10 HCl, so NO2 become NH2. Then bromine water. So all three position Br should come, but one position already occupied by previous Br. Now NaNO2 HCl, SCPO2 heat, matlab diazonium, and then reduce. Again NH2 gone. Again NH2 gone. So now we are getting this situation, and this is matching with this compound. This is product D. This is matching. So C and D is the correct answer. Bacho, are you getting this? Beta?
Sir, in
Yeah.
first step, why did you put bromine in para position, sir? P
Because-
reaction.
Because na, in the case, both positions are like activating the same. This is suppose CH3. This is suppose nitro. For nitro is meta directing. So this one is meta, this one is meta. Methyl is ortho para. So for methyl, this is ortho and this is para. So both are activating the same position. Out of these two positions, here we should not do the reaction that will create steric hindrance, because three compound will come simultaneously, right? So this is the more like appropriate position for the electrophilic substitution, right? Now come to this question, question number 5.
A and B, sir.
A and B. Okay. A and B. Okay. Anyone?
B, sir.
B. Yes, absolutely. The answer should be B only. A, how A can be the answer? Come on, please. You just explain so that we can rectify the error. How A can be the answer? Please tell me.
First diazonium, then attack from beside ring, closest nucleophile.
Okay, so you will get the same situation, right?
Yes.
Now my question is, if this become diazonium and attack to this ring, diazonium is a weak electrophile, if you remember. I'm telling you one simple thing only. Diazonium, what is N triple bond N positive, is a very weak electrophile. So that is why we need a strong nucleophile, and we use mild NaOH in case of phenol, so that it become O minus, and O minus activate the nucleophilic benzene so that it can easily attack. In this case, if you create diazonium here, this ring is not even good nucleophile. How can you attack the weak electrophile on this benzene ring, which is also the weak nucleophile? So the reaction won't happen. If this benzene can react, then any sol can also do diazo coupling reaction. While you know that benzene diazonium compound won't react with any sol directly. According to you, if this benzene is able to react with diazonium, then any sol is much better nucleophile. So any sol should react with diazonium. But any sol won't react with diazonium. This ring should not attack with diazonium. That's a basic thing only. You got this point? Now?
Yes, sir.
Very good. So only the answer is B. Because diazonium, this OH become O minus. That is understood. In that case, that ring is activated, then diazonium attack, and after the reaction work up, will again convert the O minus into OH. Right? Okay. Now you see this question, everyone. See this question. All are the replica only, JEE advanced replica.
BC.
B and C.
C and D, sir.
C and D. You see, that question is replica and easier one. Still we are facing problem. Because you always face problem in multi-choice questions. right? And you must remember one thing also, multi-choice question may have single correct answer. Single option correct may not have multiple answers, but multiple may have single correct answer. Na?
Only C, sir.
Absolutely, only C is the answer. KBRO3 with HBr meaning is bromine water itself. So you will get a tribromoaniline in that case, and which cannot match with the product. In case of D, the NH compound is again actually involved in a resonance. Right. So if you go for even for bromination, you will get a dibromo compound in that case. One is ortho and that one is para. Suppose even if I go for the reaction, at least you will get this a dibromo, na? And then after then you go for the hydrolysis only, right? In that way, if you check, only the C option is matching with the product. Only you will get para, because this is now mild activating nitrogen lone pair involved in resonance. It won't go for tribromination. Only para Br, then hydrolysis. So NH2 and para Br. NH2 become diazonium and replaced by Br with CuHBr. So you will get only 1,4-dibromobenzene in that case. So you see the question, whenever the easy question comes in JEE, it create actually confusion because you go for the deep thought. In this case, you simply went for the deep thought and you gave answer B, C, C, D, like that. Go with your basics only. Okay, I'll show you one more question. This is just standard IUPAC question. Just check this.
CD, sir.
CD. Okay. Anyone? One student gave answer CD.
Only D, sir.
Only B Bombay.
D.
Only D.
Then.
Okay. Yes, absolutely answer D only. How C is possible? 1, 2, 3. Okay, if you start 1,
did
2,
not see correctly,
3
sir. Then sorry.
tribromo, then 4 is this one. That create actually illusion. Because generally we feel that, okay, this is the fourth position, methyl or Br. So it may create illusion. That kind of a game JEE always play with the students. Right? The question is very much easy. So you will be more excited by seeing the question. Now this can I easily solve. Okay, 1, 2, 3 tribromo. That is fourth position. Okay, 4-methyl benzene. That kind of illusion they create actually. So you got, so only answer is D. No other answer is matching. You please must be like careful when you are reading the questions. Right? Okay, no worries. We'll go for the next question.
Sir, question number 6.
Yes.
For D option, so I wanted to say that with KBRO3 HBr, we wouldn't get an ortho product, like there wouldn't be a reaction.
Why?
So if I'm saying if it's sufficiently activated to give a product at ortho, then even in C option, after getting the para product, we can still get an ortho, right?
In this ortho and para, okay, I'll ask you one simple question. If you have remembered that question, whenever in aniline case, we want to get para product, we want to get mono product, what you will do? Tell me. If I want to get para product, only mono bromo product, what you will simply do in your organic part? What you will do? Tell me first.
Acetylate.
Yes, absolutely. First you will do acylation, right? Then you will do bromination, absolutely.
Yes.
And in that case, para is the major answer and ortho will be the minor answer.
Yeah.
Okay, so that only I am doing here. Because here para is blocked, that's why I am doing the position ortho. Here para is free. So if I go for the major one, the para is the only option. In this case, para is blocked, so major one will be the ortho only.
Okay.
Yeah. You got my point?
Yes.
Very good. Okay, come to this question. This is again one more replica what I have prepared.
A option, sir.
Option A.
Yes, sir.
Very good, very good, very good. Good job, yeah. Good job. This question actually, I think you all got. The topic is detection of elements, Carrier's method, right? Liebig method. You remember? So BaCl2 we use only in the case when the compound is containing sulfur. So that can create BaSO4, if you remember. We can like calculate the percentage of sulfur also by getting the formula, right? So this carriers method on treatment with Na2O2 with BaCl2 like process will get BaSO4. So the Q should be sulfur compound, and first it will do SNAR. If you remember, when leaving and withdrawing are on the ortho para position, we can do SNAR. So here PHS minus do SNAR, remove this F, will get sulfur phenyl. Here directly you can attack, you will get CH2 sulfur phenyl, and both the compounds will give this test, carriers test. So A is the correct option. Very good, very good. Now you may think some different. Sir, in this case, sulfur is already present. I can use any one of them. Anyhow, it will give carriers, but the Q is common for both. If you use any of the reagent, the M reaction will not match. So by default, you have to go with the A only. Don't be confused, right? Okay, this question. This question I have not prepared. This question directly I got from one IIT JAM exam. One JAM exam is there no, for masters. So that question actually I have got from
C, sir.
C. Okay, this one.
C option.
QPMN. Two students have given answer C. QPMN. Yes, option C is correct answer. Any discussion is required? This is easy question. Now see this question. This question is actually good one. What is the question? Scheme 1 and 2. This is again replica what I have prepared. Scheme 1, scheme 2. Describe, this question is good. Please see carefully. Scheme 1 and 2 describe the conversion of P to Q and R to S. Right? That's simple thing only. P to Q and R to S. That they are saying. Scheme 3. Scheme 3 is this one. This is scheme 3. Scheme 3 describes the synthesis of T. This is compound T from Q and S. What the Q and S we got from scheme 1 and scheme 2, those Q and S, when they are reacting after NaOH reaction, they will give the product T. Right. So this is the question. Now we need to check the correct match. Correct match. Okay. The first one you please remember, that is scheme 1. This is scheme 2. Scheme 1 is giving Q, 2 is giving S. Q and S, they react after NaOH reaction, they will give T. So correct match you need to find P, R, S, and Q. Check this question. That same kind of question already JEE have asked.
ABCD, sir.
ABCD all?
ABCD, sir.
Yes, absolutely. All are correct only. A is correct, B is correct, C is correct, D is correct. So that kind of questions, they're never tough, but they may take some time. The next part, what I have created for the same question, you see that next part also. This is scheme 1. Now the same thing, P, scheme 1 Q, scheme 2 S, and S and Q give this compound T. Now check this second question for the same theory.
C, D, sir.
Which one?
C and D.
C and D. Okay. Okay.
B, C, and D.
B, C, and D. Okay. C and D. One is saying B, C, D.
CD.
C, D. This is good question. You please see everyone carefully. Anyone? It's actually good question. You please see carefully. Not tougher one, but it's a good question. Only answer C is correct. B is wrong. D is wrong. You see carefully. See carefully. How this, like a D is correct. A, this BR you won't get, na? Come on, see carefully. Check properly. You read the things because you are focusing on the main thing. You are focusing on the main thing, this thing. You're not seeing this BR carefully. You won't get this BR here. So D is anyway eliminated. B, what you have done, you didn't write the B properly. You didn't solve the B properly. What you thought, okay, here we have monobromo, here we have tribromo. If we exchange, we'll exchange the benzene rings. Again, you check the process. Read the question carefully. Should I solve this question or you got? Because the question is not tough. You are not solving properly by seeing the option that's easy only. That is why you are getting wrong answers. One answer is correct, but other two are wrong. B you are getting, D you are getting. So you may lose answer only. Not getting. Still you are not getting answer.
Not, sir.
Not getting.
Got it, sir.
Okay. Okay. Okay, this question. Here I am asking O. Again, this is replica. All questions are replica only. That is why I am telling you, see very properly. And you see, in any replica, you are not getting any exception case. JEE won't use exception cases used generally. Exception, unnecessary reaction, they never ask.
AD, sir.
A and D.
Yes.
AD, sir.
Yes, absolutely. Answer is A and D only. Bahut badhiya. Yes, answer is A and D only. So no need to discuss this question again.
Gabriel Thalamatis.
Ah, yes, absolutely. Okay. What this NH2 is matching with what? R, S, Q, and P.
R, sir.
R. Option A.
Yes, sir.
Right. Absolutely. Very good. Very good. Very good. Okay. This question I have created from JEE only. The same type of question a few days back you got in GTA something. I think. The same kind. I only have discussed this question, but I have changed the question. This is not the reactant, the products and reagents are almost the same. What I am asking here, now you see the question what I have created. What is the question? These are PQRS, some reagents, and the product will match with these, any one of them. Now, correct statement is P is this, R is this, P has combination of second and third, right? Because if P suppose reactant, it may have combination of second and third. R has combination of second, third, fourth. Like that, you need to check. You got the question? That kind of question usually JEE asks. You may feel that nothing is given. How to solve this question? That is why read the entire question properly, then check what to do.
So can you one show top of the questions?
Nothing is there. Just simple. Only list 1 and list 2. This is list 1, that is list 2. Nothing else. Yes, Bacho, you got
A, B, C, D, sir.
A, B, yeah. Pata nahi. A, B, C, D. You are getting
Yes, sir.
ABC, sir.
A, B, C. Okay, not D. A, B, C, D is correct answer. Yeah, A, B, C, D is the correct answer. Good, yeah. Bacho. Very good. A, B, C, D is the correct answer. So, I think we have more days now and we should discuss such kind of questions only. So, next session, again, I'll discuss same kind of more 15 questions, right? So, okay. Thank you, everyone. Anything you want to discuss, you can ask. Otherwise, I'll close the session.
Sir, is it necessary to study the mechanisms of oxidation and reduction reaction?
I'm not getting your voice better. What you are saying?
Is it necessary to study oxidation and reduction mechanisms?
No. It's not required. Nothing. Of the oxidation reduction, not that much. That mechanism part, that much is not required. Reformatsky is not required. Novengel is not required. That type of reaction, G, you just go with the standard reactions, standard only. You should not forget about Perkin, Canizaro, Aldol, haloform, alcohol reaction with the SOCl2, PBr3, PCl5, right? And elimination reaction, SN1, SN2 reaction, SNI as such is not required. NGP, it may require NGP, right? And other than that, even E2, even CB, all three are required. And EI as such is not required, EI, unnecessary wastage of time. And this cyclohexane confirmation, that much depth knowledge is not required. They usually they never ask this chair and all, but the mains may ask. Advanced usually not ask the such things. And Hoffman bromamide is required. Soda lime decarboxylation is required. Ester formation, ester hydrolysis is required. Anti-addition Br2 is required. Hydroboration oxidation is required. Standard reaction, what you have actually finished, no? Those only required. Yesterday, I have shared the chemistry everyday life NCRT PDF of mine, and one chemistry everyday life question, what I have discussed, that I have shared also with you. So oxidation reduction agent you want. Okay, I'll share. That also I'll share. Right. Yeah. Thank you, everyone. Thank you.